Bismillahirrahmanirrahim. Today we are going to speak about the derivatives of inverse trigonometric functions. Before we spoke about the derivatives of the trigonometric functions, sine, cosine, tangent, cotangent, and secant. For today we are going to find the derivative of the inverse trigonometric functions. So that the objective for this topic will be to find the derivative y equal to sine x. We need to find the derivative for this one. Let's say find y prime of the given function y equal to sine inverse x. You know that the inverse trigonometric function is just a function to find the angle. So in this example, y will represent the angle of the trigonometric function. In other way, this can be written as sine of y equal to x. Y equal to sine inverse x can be written as sine of y equal to x. Now, if we differentiate this function using the implicit differentiation, by implicit differentiation, if we differentiate the left-hand side, I will have cosine of y multiplied by y prime. We mentioned this before. Anytime we differentiate with respect to x, I must have y prime. So it is cosine of y multiplied by the derivative of the angle, which is y prime, equal to the right-hand side is equal to 1. So y prime is equal to 1 over cosine y. Just 1 over cosine of y. Now let's go back to this form, sine y equal to x. We know that the trigonometric function will give some relation between the angles of, between the sides of a right triangle. Sine of y equal to x. So this is y in the right triangle. And we know that the sine equal to r, so it is the opposite divided by the hypotenuse. Opposite of this one is x now. Sine of y equal to x over 1. So the opposite is x and the hypotenuse equal to 1. Now we have the opposite, we have the hypotenuse, and we can find this side, the adjacent. From the Pythagorean theorem, we know that the adjacent is equal to square root of the hypotenuse square, which is r square minus x square. R in this example is equal to 1 minus x square. So this side is square root of 1 minus x square, which means cosine of y will be the adjacent divided by the hypotenuse. So from this one, we know cosine of y equal to 1 minus x squared divided by 1. It's the adjacent to the angle divided by the hypotenuse. So this one, now this function can be written as 1 over cosine of y, it is 1 minus x squared. So this will be the derivative of the sine inverse. Y prime equal to 1 over square root of 1 minus x squared. Then we can say now the derivative with respect to x of sine inverse x is equal to 1 over square root of 1 minus x squared. So this is the first derivative of the inverse trigonometric function. We can apply the same thing to the other inverse trigonometric functions. So this is the first one, derivative of sine inverse. Second one is exactly by the same technique, d by dx, or the derivative of cosine inverse x is equal to 1 over square root of 1 minus x squared, but with just small difference that this is minus. For the cosine inverse, the derivative is negative. It is minus 1 divided by square root of 1 minus x squared. Third one, tan inverse. The derivative of dx of tan inverse is equal to 1 over plus 1 plus x squared. For the cotangent inverse, again it is the same, 1 over 1 plus x squared, but with negative sign. It is negative. It is minus 1 over 1 plus x squared. Fifth one, second inverse. Is equal to 1 over absolute value of x multiplied by square root of x squared minus 1. And the last one is cosecant inverse. Is equal to, again, 1 over absolute value of x squared minus 1, and again we have negative sign for the cosecant inverse. So it is minus 1 divided by absolute value of x multiplied by square root of x squared minus 1. Now these are the formula for the derivatives of inverse trigonometric functions. Let's have some examples. Find y prime. First one, y equal to sine inverse of x squared. The derivative for this one, y prime equal to 1 over square root of 1 minus the angle x squared all to power 2. We go back. It is 1 minus x squared when we have x as the angle of the inverse trigonometric or the inverse trigonometric function. Now, in this example, the angle is x squared, so we have to square it. It is x squared to power 2. But also, we have to be careful about one thing. We have now x squared as angle, so we have to find the derivative of the angle by the chain rule. The derivative for x squared will give me x. What was given in the formula was the basic one, when the angle is x, but if the angle is not x, then we have to find the derivative for that one, for the angle, by the chain rule. So it is 1 over square root of 1 minus x squared all to power 2 multiplied by 2x, or I just can write it as 2x divided by square root of 1 minus x to power 4. This is the derivative of this function. Take another one. Number 2. Y equal to cosine inverse of square root of x. Now the angle for this one, or the derivative, y prime equal to minus 1 divided by square root of 1 minus the angle square, the square root of x all to power 2, multiplied by the derivative of the angle. This is by the chain rule. which is 1 over 2 square root of x. So this is the derivative, or just simply can be written as minus 1 divided by 2 square root of x multiplied by square root of 1 minus x. This is the derivative. Minus 1 divided by 2 multiplied by square root of x multiplied by 1 minus x. One more. Number 3. Y equal to tan inverse of x to the power 3. The derivative will be y prime equal to, for the tan inverse, it is 1 over plus 1. The angle is x to the power 3. All to the power 2 plus 3 multiplied by the derivative of the angle, which is a 3x squared. So it is just simply can be written as 3x squared divided by x to the power 6 plus 1. This is the derivative of this function. One more. Number 4. Y equal to tangent, let's say cotangent this time, cotangent inverse of ln of x, cotangent inverse of ln of x. Now the derivative for this one, y prime is equal to 1 over, or it is minus 1. Minus 1 divided by 1, to the angle square, and the angle in this case is ln x, multiplied by the derivative of this angle, which is ln of x, and we know the derivative is 1 over x. So this is the derivative of this function, y prime equal to minus 1 divided by ln x all square plus 1 multiplied by 1 over x. Next one, number 5. Y equal to take this time x squared multiplied by sin inverse x all to the power 3. Now for this example, we have to apply the product rule and also the chain rule and the derivative of the inverse trigonometric function. X squared multiplied by sin inverse x all to the power 3. So first of all, we have to apply the product rule because I have multiplication of two functions. So this is by product rule. By the product rule, we know that the derivative is f prime multiplied by g plus g prime multiplied by f. So the derivative now y prime is equal to the first function will give me 2x. The derivative of x squared is 2x multiplied by g, which is sine inverse x all to the power 3 plus. Now the derivative of the second function, I have power and I have inverse inside. And we know by the chain rule, we have to differentiate the power first. It is a 3 multiplied by the function to power 2. Then differentiate what is inside. Sine inverse. The derivative of sine inverse is 1 over square root of 1 minus x squared. Now this is the derivative of the second function. Don't forget I have to multiply by f. F is the first function, which is x squared. So this is the derivative. Y prime equal to x multiplied by sine inverse x to the power 3 plus 3 times sine inverse x all to the power 2 multiplied by 1 divided by 1 square root of 1 minus x squared multiplied by x squared. This x squared, it is the function, that is the first function. F prime g plus g prime f. Number 6. Before doing this, you write one remark. We said sine inverse x, this doesn't mean it is 1 over sine. Sine inverse, this notation means the inverse trigonometric function. If I want to write it as a power, I mean minus 1 as a power, I will write it in a bracket. For example, I will say that y equal to sine, not inverse, sine x all to power minus 1. In this example, minus 1 here is power. This is power. This is not the notation of the inverse trigonometric function. I have to be careful about this one. When it is written in this form, we mean it is to power minus 1, not the inverse trigonometric function. So the derivative in this case, y prime is equal to minus 1 as the power, then minus 2. We know for the derivatives, when we differentiate the power, we subtract minus 1. We take 1 from the power. So minus 1, for the derivative, it is minus 1, minus 1. So minus 1 will give me minus 2. And keeping the sign as it is inside. Now, differentiate what is inside the power. The derivative of sine will be cosine x. Now this is the derivative. We have to be careful about the notations. When it is power or when it is inverse. Sometimes you can combine between these two. Number 7, for example, if I say that the function y equal to cosine inverse x power minus 1. You can see in this example I have power minus 1 and I have inverse notation cosine to power minus 1 or cosine inverse. This notation should be clear. The outer one is power, the interior one, the inside is the inverse trigonometric function. This is power and this is inverse. So the derivative now y prime is equal to, first of all we differentiate the power. It is minus 1 multiplied bracket to power minus 2. Minus 1 will give me minus 2. We deduct 1 from the power. What is inside is cosine inverse. Now the next step we have to find the derivative of what is inside. This will be multiplied by derivative of cosine inverse is minus 1 divided by square root of 1 minus x squared. It just can be written as minus 1 with minus 1. It will be 1 over square root of 1 minus x squared multiplied by cosine inverse x to the power minus 2. So I will have something like this one. It is 1 over square root of 1 minus x squared multiplied by cosine inverse all to the power minus 2, and that will be the derivative of this function. So we have to be careful about the derivatives and the power. They are not the same. One more example, number 8. Y equal to ln of second inverse of x. And we need to find the derivative. Derivative of ln is 1 over the function given there. One over second inverse x, then we find the derivative of the function. The derivative of second inverse is 1 over absolute value of x square root of the angle square minus 1. This is the derivative. 1 over second inverse x multiplied by 1 over absolute value of x multiplied by square root of x square minus 1. One more example. Number 9. Y equal to, let me take this time, tan inverse of e to power 2x minus 1. And the derivative of this one, just direct application for the formula that we have, y prime equal to, for the tan inverse, is 1 over the angle square plus 1. The angle is e to power 2x minus 1. Then, let's find the derivative of this angle, e to power 2x minus 1 from the last section, the derivative of exponential function. The derivative of the exponential function will be as it is, e to power 2x minus 1 multiplied by the derivative of the power, which is 2. This is the derivative of the angle. So it is 1 over the angle square plus 1 multiplied by the derivative of the angle, and in this case it is exponential function. So it is e to the power 2x minus 1 multiplied by the derivative of the power, and if the base is not e, we will multiply it by ln of the base. But since the base is e, no need to write it. So this is the derivative, y prime is equal to 2 multiplied by e to the power 2x minus 1 divided by e to the power 2x minus 1 square plus 1. And this is the derivative of the given function.